Hello! Today we're going to start delving into trigonometry by working on something called the tangent. You know it's important because I've already put the name down twice. Now, tangent is really, we're only going to use it for right triangles. The trig that we're going to be doing is really going to be right triangle centric. Okay, and for the immediate future. We're going to be using it in right triangles, and sometimes this can be abbreviated as tan, okay, but we still call that tangent. Now, we take the tangent of an angle, and rather than call that angle x, we usually refer to it as theta. Right there, that is theta. And theta is just an angle we're going to choose in a triangle, and the tangent of theta is always going to equal the opposite side over the adjacent side of a right triangle. So if I've got a right triangle that is, whoa, this is like a really bad right triangle. My apologies. Okay, but assume this is a nice one. Sorry. Let's say we're working on an angle right there. This is our theta. So this side, the longest side, which also is across from the right angle, this is our hypotenuse. This one is not going to change. Our opposite and our adjacent, though, can change depending on what our theta is. So if this is our theta, the side that is totally across from the angle is going to be our opposite side. And the side that forms the angle, along with the hypotenuse, is our adjacent side. So the opposite is always way across there, adjacent one is always forming the angle, and the hypotenuse is always across from the right angle there. Okay? Make a note of these. These are important. We're going to be using these a fair bit. So the first thing to using tangent productively, we're going to scroll down a little bit here. Alright, so we've got a triangle here. It's saying find the tangent of A. And what we're looking for here is a ratio. We're looking for a tangent ratio. So first thing we need to do is identify our angle. We have triangle ABC. Where's angle A? Angle A is right down here. So this is our theta. And our tangent of theta, remember, is opposite. I'm going to just abbreviate OPP over adjacent, ATJ. We're looking for the tangent of angle A. So I'm going to say I'm going to look across from this angle all the way up here. The one that does not form the angle, hey, that's 27. So 27 goes on top. And then I'm going to look for what is adjacent. This is a hypotenuse, so we're not going to use this guy right now, the 45. This 36, though, that's our adjacent. So 27 over 36, we can reduce this. Divide the top and the bottom by 9, and we get 3 over 4. That's our answer. The tangent of angle A is simply 3 over 4. We are done. Let's try another one real quick. Okay. Tangent of angle A. Where is our angle A? Right up here. We'll call that theta. I just like calling it theta. Looks so nice and Greek lettery. Tangent of A is going to equal our opposite. What is our opposite of angle A? 20 over our what? Over our adjacent. Adjacent is 21. Don't let this guy confuse you. This is our hypotenuse. Right now, when you're working with tangent, you're only concerned with the opposite and the adjacent, so we're not going to be using the hypotenuse really right now. We'll come back to it later, but not right now. So, what is this used for, you ask? Okay, well, let's see. Oh, what is this? We've got a missing side. We know we've got this side, we've got an angle measure here, and we've got this missing side. If we treat this angle right here as our theta, okay? Again, let me write down the formula. Tangent of theta is just your opposite over your adjacent. Let us plug in 63 into here. Now this tangent of 63 is a number. If you actually look up what this is, this is the tangent of 63. It's 1 point, wait a second. Yes. It's 1.962. This guy goes on forever. It's an irrational number. But we can round it here to about 1.96. This is the tangent of 63. So we can't split this. If we multiply this tangent of 63 by anything, we cannot change this 63 in here. This guy is locked in. This tangent and this 63, they go together. Don't mix them up. Don't mix them up. They are like glued together here. We cannot alter this. So if we're going to do anything, remember this is actually a number, in this case about 1.96. We can't really change that too much. So leave these together. Don't mix, don't distribute anything in here. They are as they are. They are the tangent of 63. This is equal to our opposite, which is this x, over our adjacent, which is 10. And we said this is 1.96. Let's go ahead and bring that down. That's just my tangent of 63, right? Is equal to x over 10. Hey, how about this? This is like all of a sudden become a super easy problem. We can totally figure out what x is. In order to solve for x, what must we do? Well, we must multiply both sides by 10. It is an equation. We need to keep both sides even. The 10's cancel out there. 10 times 1.96 simply leaves you with 19.6 equals x. And that's it. We now know what this side is, 19.6. Let us try one more. So I've got set up as such. Remember, tangent of theta equals opposite over adjacent. Let's put that formula up there. So when I'm working on this problem, I'm going to take the tangent of what? I've got 24 degrees right here. This guy is going to be my theta. Tangent 24 equals, what is my opposite? 15 is my opposite. Adjacent, there's x. Now this time I'm not going to put this tangent of 24 into my calculator right away. It is a number, but in general I like to save all my calculator work to the very end so that I don't have to keep going back and forth to it. It also helps reduce calculator errors. So first thing to solving this, what should I do? I've got stuff in the denominator over there I want to clear out, particularly this x. Well, let's multiply both of these by this x. Got to do it by both sides, keep the equation even. This cancels out then, so x is gone. So now we have x times tangent of 24 equals 15. We want to get the x by itself, so we can divide both sides by the tangent of 24. These cancel. So we get x equals 15 over the tangent of 24. Now, this is mighty nice to put into our calculator. 15 divided by the tangent of 24. So I'm going to do 15, let's see. 24, the tangent of 24, that's, what about 0.4, I'll say 0.45. So I'm going to do 15 divided by 0.45 gives us 33.3 repeating. So I'm going to have x equals 33 point, we'll round to the nearest tenth, 33.3. That is it. That is how we can solve for a missing side. We set it up, and using a little bit of algebra, we can totally solve it. So practice this. Think if you have questions. Think on those questions. And let's be awesome. Have a wonderful and productive day.